Hello all. So let us work out some numerical questions. From my side, I will make sure that every numeric question ever asked will be explained to you. From your side, what you have to do is three things. One, maintain a notebook for these numeric questions itself. A large size notebook where you have written detailed out every simple thing which has been explained to you. See, I have few notebooks which I have been still maintaining it from my UG. Also, second point, have a 80 pages notebook. Wherever I tell you that you have to memorize this, then just write it down in that separate notebook. Third point, whatever being taught, please attend the test in the website. With you doing these three things, I can assure that you will attend these questions with utter confidence in the examination. So let's start with the questions. So next question, a neighborhood with a total area of 200 hectares has a gross density of 300 persons per hectare. If the residential area is 60% of the total, then the net density in persons per hectare of the neighborhood is. So what have they given? The total area. Total area means gross area. Gross means total. Okay. Total area is 200 hectares. Gross density 300 persons per hectare. Residential area is equal to 60% of the total. Therefore, they are asking the net density. So that is in persons per hectare they are asking. Okay. Now first let us write what they have asked, how to get it. So they have asked solution net density. What is the formula for net density? That is the population. Actually it is net population. Population by net area. So what is the net area over here? Your residential area is the net area. So how much is the net area? 60% of total area. So 0.60 into 200. And what is the population? We don't know. So we have to find the population here. We know the net area. We don't know population. So what else they have given over here? They have given a gross density. So we'll try to find the population from the gross density. So gross density, what is the formula? For gross density, it is total. That is your gross population divided by gross area. So what is your gross density? That is 300 persons per hectare. What is the total population? That's what we are trying to find over here. Population. And what is the gross area? Which is 200. So your total population will be 60,000. So just transfer it over here. That is, therefore your net density is equal to 60,000 divided by 0.60 into 200, which is 500 persons per hectare. Okay, so this is your answer. Your next question, a town with a population of 50,000 has an average household 5. The number of occupied dwelling units are 8,400, of which 10% are in dilapidated condition. The housing demand of the town is okay. Let us write what is given first. What is the population? 50,000. Household size is 5. Occupied dwelling units. So there are already 8,400 dwelling units which are being occupied, and dilapidated condition, which means the households which cannot be used. Is equal to 10%. So there are already 8,400 occupied dwelling units, out of which 10% cannot be used, and they want a household for that also. Okay, so they are asking housing demand, means
how many housing more is required? First, let us find out how many housing is required for the actual population. Actual required housing. So this is the solution. Housing is equal to 50,000 population divided by household size. So that becomes 10,000 dwelling units are actually required. But how many are there? There are only 8,400. Available are 8,400 minus 10% of 8,400. Because 10% also cannot be used. So let us reduce that also. So that becomes minus 0.1 into 8,400. So that is 8,400 minus 840. Okay, just keep this value like this. So therefore, required housing is equal to housing demand equal to this. Actually 10,000 housings are required, but how many we want? 10,000 minus 8,400 minus 840. Okay, so that becomes 10,000 minus 8,400 plus 840, minus and minus it becomes plus. Okay, your final answer you will be getting as 2,440 DU, dwelling units. Okay.
A building has a rooftop area of 300 meters square. If the average annual rainfall in the region is 700 millimeters and the runoff coefficient of the rooftop is 0.8, then the maximum amount of rainfall that can be harvested from the rooftop in liters is. So let us first write what is given. See, by now you would have solved these questions like twice or thrice in our videos. But there is only one difference over here. So every question will be varying in a slight difference. In this question they have asked us in liters. So that is the different question. So what is given? Area 300 meters square. Your rainfall intensity is 700 millimeters. Because your area is in meter square, let us convert it to meter, which becomes 0.7 meters. And your runoff coefficient is equal to 0.8. Maximum amount of rainfall is equal to what? Okay. See, because you have solved these questions twice or thrice, I'm sure you right now know the formula for it. So all of you will be solving it up to the formula. You will be substituting the values over there and you will be getting the answer. But where you might have a chance of making mistake is converting it to the required units. The question plays with the unit. So here they have asked us in unit liters. So the solution for it is, we know Q is equal to C into I into A. This is your formula. Quantity of rainfall, runoff coefficient, intensity of rainfall, and the area, rooftop area. So the coefficient is 0.8. Intensity is 0.7. Area is 300 meter square, which gives you a value of 168 meter cube. Now, does your answer get over here? No. They have asked us in liters. We know that 1 meter cube is equal to 1000 liters. What is your... So, how many liters for 168 meter cube? That becomes 168 into 1000 liters. Right? Forget this one. So, 1,68,000 liters is your final answer. A seminar hall has a volume of 2000 cubic meter and the total absorption of all acoustic materials without any audience is 80 meter square subimes. The reverberation time of the empty hall in seconds will be. So, given volume is equal to 2000 meter cube. Absorption is equal to 80 meter square. Reverberation time is equal to dash seconds. We know the formula.
solution is equal to reverberation time is equal to 0.16 into volume by A. So 0.16 into your volume, which is 2000 meter cube, divided by 80, for which you will get an answer of 4 seconds. See, we are solving the question papers. We are solving the question papers and numeric questions of all the questions which has ever come in your GATE exam question paper. So if you find some of the questions patterns to be repeating, then just try to understand that that type of question is that much important. So don't get bored about the type of questions. Instead, try to understand in this way. They have asked these type of questions that many number of times. In acoustic there are only few varieties of questions which would be lingering around the same formula. Okay.